Okay, let's sketch some sinusoids. First of all, we want to look at the equation. And we want to notice that we have an amplitude, and that goes in front of the curve name, whether it's a sine, cosine, tangent, whatever. We also have a period, and that's the one in blue here, and that goes right after the sine, cosine, tangent, whatever. And then we have a phase angle, and that goes in the parentheses if there is one. And the x can either be an x or a theta. Don't forget that. And then D, our center line or our vertical shift, that can either be at the end of the equation or at the beginning of the equation. Let's take a look at a couple of these here. You will notice that our amplitude for this first equation is 2. It is a sine curve. It is a positive sine curve because the 2 is positive. And the period is 3. And the phase angle will be a positive 45 degrees. Even though it says x minus 45 degrees, the angle is then always positive, or the opposite. If this is a negative, it's a positive. And our center line, our vertical shift, is at negative 10. If we look at the next one, here we have y equals 5 minus 2 cosine x. The 5, you'll notice, is the center line. It's shifted to the front of the graph. This is a cosine curve with an amplitude of 2. The amplitude is always positive, but this is a negative cosine curve. And we have no phase shift here at all. And we have a standard period. There's nothing in front of the x, so it's a standard period of 2 pi or 360 degrees. Whenever there's nothing right here, that means there's the invisible 1, which means that our period is going to be 2 pi or 360 degrees. Now look at this last equation here. What we have here is an amplitude of 5. Even though it says negative 5, it's an amplitude of 5. Although it is a negative sine curve, I want you to look at what we have here for our phase angle, because we don't have anything outside the parentheses, which means we have a problem because we do not have a period. We have to factor in order to make it what we need in order to graph it. So what we're going to do is we're going to divide everything in here by 12. We're going to pull it out, factor it out, and we're going to be left with this, so that we can see that we have 12 outside the parentheses, and when we divide pi by 12, we end up with a phase shift of negative pi over 12. Again, our phase angle will be negative pi over 12, but when we look at our equation, it's the opposite. It's x plus pi over 12. All right, let's get started. Here we have a sine curve. We first look for our amplitude and our center line. Our amplitude is 2. Our center line is negative 10. Therefore, we will have a dashed line instead of a solid line. If we were at 0, it would be a solid line. But here we're at negative 10. In order to find our upper and our lower values, we're going to take negative 10 and add our amplitude, which is 2, and we will get a negative 8. Down here, we will subtract our amplitude, which is 2, and we will get a negative 12. So we have our minimum, or our middle line here, our center line. We have an upper value of negative 8 and a lower value of negative 12. Okay, where do we start? We have to check our phase angle. Here in our equation, it says x minus 45 degrees. Therefore, our phase angle is going to be 45 degrees. That's where we will start this graph. It is a sine curve, so we know it's going to start crossing the, whoops, not the x-axis. But it's going to cross this x scale that we have created. This, not quite the x-axis, I guess I could call it. We're going to start it at 45. We also need to know what our period is. So here our period is 3. And since this is in degrees, we're going to use degrees. So 360 divided by 3 is 120 degrees. That means, as we move ahead, that's what we're going to use to figure out where our one cycle stops. It starts at 45. So we'll take 45, add our period of 120, and we get 165. So our sine curve will start at 45 degrees and will end at 165 for one curve or one period or one cycle, any one of those. Moving on. We need the middle point. Now you can pretty much eyeball what the middle is going to be, but when we have a 120-degree period, all we have to do is add half of that, which is 60, and it'll give us 105 degrees. Okay, so that means here we are in the middle. We've got our beginning, we have our middle, and we have our end. Now let's don't forget that we have a sine curve. And that means it's going to cross up here, it's going to come down here, and it's going to end over here. They, of course, continue on and on and on and on. Oops, let me get this out of here. And we are going to next plot our other 2 points because we want to be as accurate in our graph as possible. So what we're going to do is we're going to start at 45, like I said. Now, somewhere between 45 and 105, we're going to eyeball the middle and put our next point up at -8. If this was a negative sine curve, it would be going in the opposite direction. But we're going to cross going up at 45. We're going to hit -8. We're going to come down to 105. Our next point is going to be between 105 and 165. And we are going to eyeball that as well. So we know that we're going to come up, come down, come back up, and then we would start a whole nother curve. So, connect our points, and this is what we get. Isn't it lovely? But we're not done yet. We need to create what is our last piece. Whoops. Hold everything, my friends. Our last piece, which is our y-axis. And the only way that we can do that is if we take 45 degrees and we're going to subtract half of our period so that we have a -15, because we know it has to be at 0. And 0, if we've got 45, 0 can be anywhere beyond this. So we will be a little bit more accurate and we will put in -15. So we know that our y-axis is going to be somewhere a little closer to -15 than to 45. And we are done. Isn't that beautiful? Let's move on and try a cosine curve. All right, looking at our equation here, we have an amplitude of 4 and a center line of -2. That means we'll put our center line here. We will add 4 and get our top or maximum value, which is going to be a 2. And we will subtract 4. -2 minus 4 will give us a -6 to give us our minimum value, which is going to be -6. Do not forget, this is a cosine curve. It's going to look a little bit different. Okay, so now we get to the big stuff. Because we have a phase shift of 2 pi over 3, our phase angle is going to be at -2 pi over 3, which means that's where we're going to start. But again, it's a cosine curve, so that means we're going to start up at the top at 2. And then we're going to come down and then go back up. So again, our phase angle is -2 pi over 3. That's where we will start. Now we have to figure out where we're going to end. So we're going to take our period. We've got a 2 here. We're going to go 2 pi divided by 2, and we get pi. So that means we have to add pi to 2 pi over 3, or to -2 pi over 3. So we're going to come down here. I'm going to give it a common denominator of 3, and we're going to add these together. Because this is -2/3 and this is +2/3, we end up with a +1/3, which is pi over 3. That's where we're going to stop. We start at the beginning at the phase angle, and we're going to end after 1 period. Now we have to find our middle period, or our middle point. And that's a little bit harder because we're going to have to add half again of our period. In this case, our period is pi, so we're going to add half of a pi. So I have negative 2/3 pi plus a half of a pi. We have to give them a common denominator of 6, and when we do that, we'll end up with negative 1/6 pi, which we will call negative pi over 6. Now don't forget that this is the middle point of a cosine curve. So it's going to start up here, it's going to come down, it's going to go to its minimum value of negative 6, and then it's going to come back up, and that will be one cycle or one full period. Next, we plot all the points. We're going to eyeball in between these two our phase angle and the middle, and we're going to put a point there, and we're going to eyeball between the middle and where we stop and put another point there. Do not forget that a positive cosine curve starts at the maximum point of the phase angle up here. If it's a negative cosine curve, it's going to start down here and go up like that. So here we are. Most cosine curves, if you put them in correctly and if you're careful about your spacing, are going to look like a really nice V. Then all you have to do is connect all of your points, and you can see this would keep right on going. We are, however, not quite done yet because we don't have an x-axis. Here it's negative 2 and this is 2, so our x-axis would actually be somewhere up here, but we don't have to put that in. We do have to put our y-axis in though, and that is going to be again at 0. So it's going to be somewhere between negative pi over 6 and pi over 3. We do the best we can to put it as close as we can to 0, and that's going to be about right here. So we want to plop that in, and then voila, we are done. This is our beautiful curve that came from this equation. Your turn. Here we go. I want you to graph this curve. It's simpler because we have just 5 minus 2 cosine x. It is a cosine curve, obviously. The amplitude is 2. Even though it says minus 2, the amplitude is always positive. Our center line is at 5. Because there is nothing in front of the x, it's like there's the invisible 1 here that we never actually write. We just leave it there. And therefore, our period is going to be either 360 or 2 pi. Since there is no indication here of whether you should use radians or degrees, you can use either one. Since the x is all by itself, or if it were a theta, it would be all by itself, there is no phase angle. So you can pause the video here and give that a try. Okay, you should have tried it on your own, and this is what it should look like. Again, here is our y-axis. We don't have to do a dashed line because we are starting at 0. It's a cosine curve, but negative, so it starts down here at 3, and it's going to go up at, if our period is going to be 2 pi, or 360 degrees, that means it's going to start down here, go up to 7, and come right back down to 2 pi. And our middle term is going to be pi. It's going to be half of our period. And then we would put in our extra points, and there we have it. Again, this is 3, this is 5, this is 7. This is not our x-axis. Our x-axis would be somewhere down here because it would be 2, 1, 0, and that would be where our x-axis is. So don't forget to make this a dashed line. It is very important that you are accurate about these things. Also, don't forget to try and be as accurate as possible about where you place your points. If you have points that are too close together or too far apart, it makes everything look really strange. So do your best. And I'll see you tomorrow.